Section 7-5 is about proportions in triangles. And we're start off by talking about the side-splitter theorem, which is actually a pretty funny name if you think about it. And the theorem says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. Okay, so in this diagram down here, if RS is parallel to XY, then XR, this length, divided by RQ, this length, will be, that ratio will be equal to YS, this length, over this length. Okay, we kind of explain briefly why that is, although it won't be sufficient for a proof. Since these lines are parallel, we know that these lengths are corresponding angles and they're congruent. Okay, similarly, these two angles are also corresponding angles and they're congruent. So it's easy to see that this smaller triangle and the big triangle are similar to each other. Okay, but those aren't the lengths that we're looking at in the side-splitter theorem. We're looking at this piece and this piece and this piece and this piece. So if you think about looking at the overall big triangle, you are kind of taking off a piece that is proportional to this piece. That has a common ratio. And because you're taking off those pieces with a common ratio, what you're left with are some sides that are still proportional to each other. Okay, that's the side-splitter theorem. And let's look at some problems to help you really see how that's used. Okay, the question is, what is the value of x in this diagram? Okay, now the way I like to look at the side-splitter theorem or problems like this is it's kind of sitting in the problem exactly how you want it in your proportion. I just think about drawing a line here, and putting it in equals. So 12 over x plus 1 is equal to 9 over x. Okay, and that's our proportion, and we solve it. Now let me warn you before we solve it that I would consider this more of an exposure level proportion because it has two terms right here. Okay, but we'll solve it anyway. I will solve it by cross multiplying. 12 times x is 12x, and 9 times x plus 1 is equal to, let's see here, 9 times x plus 1. I distribute the 9 because I'm multiplying 9 times x and 1. So 12x is equal to 9x plus 9. And I will solve this by subtracting 9x from both sides to get my x's together. 3x is equal to, let's see here, 9. Divide both sides by 3, and x is equal to 3. Okay? So it's not too challenging. Another problem, what is the value of a in this diagram? Again, it's sitting in a format that looks very much like our proportion. I draw a line here, equals this line, a over a plus 4 is equal to 12 over 18. Again, because I have two terms here, it's more of an exposure level question, but we'll go ahead and solve it. Cross multiply, a times 18 is 18a, is equal to 12 times a plus 4, which is 12 times a plus 4. And I will multiply 12 and a plus 4 by distributing the 12. 18a is equal to 12a plus 12 times 4 is 48. I will subtract 12a from both sides. 6a is equal to 48. Divide both sides by 6. And a is equal to 8. Okay, and that's it on the side-splitter theorem. Let's look at a corollary to the side-splitter theorem. It's very much related to the side-splitter theorem, but now we don't have triangles. If three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So I can look at this, and since these are parallel to each other, that the length AB divided by the length BC will be equal to WX divided by XY. Now, I don't know if this reminds you of Theorem 6-5 7 from section 6-2 on where we said that if this was congruent to this, then this was congruent to this. I don't know if you remember that or not. But if you do, this is more of a general idea, a general statement about that same idea. Now, they don't have to be equal. We just know that they will be proportional. Okay, let's look at one problem with this. I will find the length of the coastline on site A. Okay, now I know since these lines are all parallel, that all the segments are cut off proportionally to each other. Now I know this ratio. Okay, and I'll use that to find the coastline on site A. Okay, so what I'll look at is I like to keep things very much as they sit in the picture. So I'll look at x over 9, the ratio of coastline to the street line is equal to 8 over 7.2. Okay, and I'll solve this proportion by cross multiplying. 9 times 8 is 72. X times 7.2 is 7.2x. Divide both sides by 7.2, and x is equal to 10. Okay, not too challenging. Let's try one more. Again, keeping things as they sit in the picture. 3x over 7.5 is equal to 4 over 2.5x. Now, if you want to do it differently, for example, more like it was in the last one of 4 over 3x is equal to 2.5 over 7.5, you can. As long as you keep the ratio consistent in the proportion, you can solve it in more than one way. Okay, let's cross multiply. So 3x times 2.5x is, let's see here, 3 times 2.5 is 7.5. And x times x is x squared. Now 4 times 7.5 is 30. And now this is probably a different kind of equation than you're used to seeing, but right now x squared is being multiplied by 7.5. So the way I get rid of a multiplied by 7.5 is to divide both sides by 7.5. And 30 divided by 7.5 is 4. So x squared equals 4. And I will undo a squared by taking the square root. X is equal to the square root of 4, or it's equal to 2. Okay, so x is equal to 2. All right, let's switch gears a little bit and talk about the triangle angle bisector theorem. Okay, if a ray bisects an angle of a triangle, then it will divide the opposite side into two segments that are proportional to the two other sides of the triangle. Okay, so in this picture, AD, ray AD, is an angle bisector for angle A. And what it means is that the ratio of CD divided by DB will be equal to CA over BA. Okay, I won't really explain why because it's a little confusing about why it works, but it does work. Okay, so in this picture, I know that 9.6 over 16 is equal to y over 24. So the ratio I'm looking at is a ratio of, of left triangle to right triangle is equal to left triangle to right triangle. Okay. Instead of this, you could write the proportion of, as it's sitting here, as I tend to do, y over 9.6 is equal to 24 over 16. Either one would be correct. In fact, these two are the same by the reciprocal property and by the switch property. Okay, so let's solve this. 9.6 times 24 is 230.4 is equal to 16y. I will divide both sides by 16. And y is equal to 14.4. Okay, let's try one more. I will just set this up kind of the way it's sitting. So 6 over 9 is equal to x minus 4 over x. Again, this is more of an exposure level proportion, but we'll still solve it. 6 times x is 6x. 9 times x minus 4 is 9 times x minus 4. Okay, now I multiply 9 times x and minus 4. So I'll distribute 6x is equal to 9x minus 36. And then I will solve this by, let's see here, subtracting 9x from both sides to get the 9's, x is on one side and the number's on the other. Negative 3x is equal to negative 36. So I'll solve this by dividing both sides by negative 3, the number in front of x, and x is equal to 12. Okay, not too challenging. Okay, so just the last couple of questions to kind of reinforce these ideas. Looking at this, these parallel lines, I know that a over b, which is a over b, is going to be equal to d over e. Okay, number 2, let's see here. On this side, it's e over f. So e over f is equal to b over c. Okay, number 4, what is the value of x in each figure? Okay, now in this one, it's actually a pretty good question. And I want to use the Side-Splitter Theorem. I know on this side it's x over 10. Okay, it's this over this. But on this side, it's not so clear what to use. Okay, what corresponds with x? Well, it's this length right here. But that length is, let's see here, 45 minus 30 is 15. So this length right here is 15, and that's the length that corresponds with x. So it's equal to 15 over, let's see here, 30 corresponds with 10. 15 over 30. And I'll solve this by cross multiplying. 10 times 15 is 150. X times 30 is 30x. Divide both sides by 30. And x is equal to 5. Okay, that's kind of a good question. Number 5 uses the angle bisector theorem. I will use 12 over x is equal to 16 over 20. 12 times 20 is 240. X times 16 is 16x. Divide both sides by 16. And x is equal to 15. Okay, that wraps up the ideas of proportions in triangles using the Side-Splitter Theorem and the angle bisector theorem and those ideas.